So let's get started. I may be restating the obvious, but collections are fundamental, important aspects of programming languages, just like keys, operators, statements, and such. They're used in pretty much every application except for the most trivial ones. In fact, I'm going to quote Kent Beck in one of his books said, "Collections hover in a strange world halfway between a programming language construct and a library. Collections are so universally useful, and their use is so well understood that it almost seems time to have a mainstream language that supports collections as first-class language elements. Until collections are first-class language elements, it is important to know how to use the current collection library to express common ideas in straightforward ways." End quote. Now, Java replaced what was at the time rich collection libraries of its predecessors with minimalist approach to collections. Minimalist here refers not necessarily to the number of classes and number of interfaces, APIs it supports, but really to various patterns that the APIs support. And right now, what we start seeing is some contemporary languages attempt to recreate the richness of humane interfaces of the past. And so do dozens of Java collection libraries. We highlight some of the problems with the existing minimalist approach in Java and also ways to address these problems. We will look into why so many people, so many companies invest so much effort in development and collection space and what problems they're trying to solve. And one of the key points we would like you to get out of this talk is that you should think in terms of behavioral patterns and not in terms of loops and iterators when you deal with collections. We will share some of our experience implementing these patterns. And until Java offers some assistance in the core language, we hope that you identify these patterns in your applications, as well as anti-patterns you may encounter, and take advantage of some of the refactorings and some of the solutions that we discuss. Okay, so here we'll attempt to show what is that we're talking about when we refer to this flurry of activity in the collection space. We will plot on the timeline various collection implementations in languages or libraries as they appeared, and you will probably see a trend there. And so on the timeline, to see the very big picture, we start by traveling far back in time. So, the very first high-level programming languages, like Lisp and Fortran, didn't have much in the way of collections or complex data structures. You had your lists and trees or arrays, and the behavior was entirely external to these data structures. If you wanted to do something, you had to write a loop. Now, if we fast forward 20 to 25 years, you will see Smalltalk coming out with rich collection library, which internalizes a number of behavioral patterns. And we will cover those in more detail later and what it means to you as the user of the language. Now, if we fast forward again, 15 or so years, Java enters the stage, and a strange thing happens. First of all, Java, intentionally by design, rather than out of ignorance, moves away from Smalltalk-like approach to collection hierarchy and goes in an entirely different direction. And again, we'll explain later what it means and what it means specifically to you and your code. And for a while, everything was quiet on the collection front. There was occasional collection library developed here and there, including valiant effort by Doug Lee. And then, all of a sudden, you witness an explosion of activity in that space. So, you don't need to read, and you probably can't read what those things are, but these are all collection frameworks, collection libraries, just in Java space, created in the past. All these efforts are trying to solve. And to answer it, let us take a more detailed look on Java approach to collection space, especially how it compares to some of the other approaches.
Okay, thank you, Vlad, and thank you everyone for having us present again. So what I'm going to do now is actually go through a comparison of some representative languages from what we call the classical era to what we now call the Renaissance, and also compare them to what we now have available in Java. So if I could just take a straw poll from the audience, how many people know Smalltalk or have heard of it? Okay, very few. Okay, that helps me out. So what I'm going to do now is talk a little bit about Smalltalk 80. So if we, basically take a step back in time, about 30 years, Smalltalk 80 came out. Smalltalk was the first pure object-oriented language. It was developed at Xerox PARC in the late 60s, early 70s, and finally came out with a public release in 80 in the form of Smalltalk 80. Now, Smalltalk 80 came out, and various books came out, and there was a description of basically the collection hierarchy. So if you look at the hierarchy of collections in Smalltalk, at the root you have a class called collection. This collection class, where all of the things actually hang off of it, like bags and sets and dictionaries. Dictionaries are the equivalents of maps in Java. You also have arrays, strings, symbols, intervals, linked lists. These are all collections. Now, collection at the base actually has a very rich iteration protocol. It has enumeration patterns, it has query patterns, it also has conversion patterns. Working in Smalltalk back in the day, it was very easy for a developer to go in and understand the framework because they'd go into the class hierarchy browser for Smalltalk and see at the top I have collection, and I can actually drill down from there and see the various types. And it's very easy for me to learn the various collections because I know at the base they share this common protocol, and I have an expectation of what I can actually get out of these collections. Now if we fast forward about 20 years, we then see the Java collection interface hierarchy that was introduced in JDK 1.2. Now what you can see is over the years, and I've got various classes on here, I don't know if you can make them out from back there, I've indicated for each of the interfaces or classes that get introduced when in the JDK version number they actually got introduced. JDK has a very interesting philosophy of basically, they want to support backwards compatibility. It's a noble philosophy. It's nice to know that, hey, when I'm compiling my code, nothing's going to break. What happens is basically, you can introduce stuff into the library, but you can never get rid of it. It's there for all time. And what you get are these, what we refer to as lava flows, where stuff gets in there, it's maybe fresh at some point, but then it hardens and you can't do anything about it. It can never change. So if you look at the hierarchy here, though, this is not actually a hierarchy, right? There's no single root. This is actually what's referred to as a heterarchy. So to quote from Wikipedia, a heterarchy is a system of organization replete with overlap, multiplicity, mixed ascendancy, and or divergent but coexistent patterns of relation. So interesting, you say like, hey, I've got in Java a collection framework, right? So you've got at the root, it was collection as of 1.2. They actually extracted iterable in 1.5. What's interesting is you've got things like arrays and strings. In Smalltalk, those were collections, right? They're not collections in Java. They're different types. Now, you can iterate over them, but you have to iterate differently. You can also see, and this is actually surprising for some people when I talk to them, map is not a collection. Now, map is in the collection framework, but it is not a collection. You can say, well, it's actually, the way Java represents it, it's actually 3 different collections. It's a key set, it's values, it's entry set. So the interesting thing, I guess, to note here as well, and this is where it kind of diverges between Smalltalk, at the root, iterable and collection, these do not have a rich API at all. It's a very minimalist API, and this is really the design philosophy that Java has baked into its collection hierarchy. So iterable gives you iterator. Collection, in terms of iteration protocol, gives you toArray. It used to give you iterator, that was boiled out into iterable. So pretty much, that's the common API that you get for iteration patterns across the various containers that are exposed in the Java collection API. Now, if we step back in time, back to 1997, Kent Beck wrote a book called Smalltalk Best Practice Patterns. It's an excellent book. I recommend it to pretty much any Java developer or any OO developer I work with. You don't have to know Smalltalk. It's going to help you regardless.
That was unexpected.
Yes. Bring it back.
Okay, where is our helpful helper?
I think we've run out of battery power.
Okay.
Sorry about that.
Apologies. Okay.
No, it's plugged in.
That's plugged in? Well, no. Hold on. Let's see if the other end is plugged in. No!
Well, it's not.
That explains a lot. Excellent. Well, we just solved the technical problem, which should greatly increase our credibility with the audience. I guess it needs to stand by.
I have to close it now.
Wait.
Kent Beck actually introduced these idea of, he didn't refer to it back then, but they were really implementation patterns. They're things that you do all the time in your code. Now, it was specifically in Smalltalk he was identifying these things. He had a section in the book called collection patterns, and then in the collection pattern section, he identified several different behavioral patterns he recognized in Smalltalk. So there was do. Some people might know that as for each. There was select, reject, collect, detect, inject into. What we call the Dr. Seuss API because it rhymes and it's very easy to remember. So back in the day, we didn't have code assist in Smalltalk, so remembering things was helpful. Now you flash forward 10 years, and Kent Beck writes a second book. Now the second book, Implementation Patterns, also an excellent book. I'd recommend it for any Java developer. Implementation patterns didn't do it, so you get what you get and you don't get upset. So we move on. Now you flash forward to current day. So how many people have heard of Scala? Okay, a few. So Scala is a static language built on top of the JVM. It's actually written by a guy named Martin Odersky. It's interesting looking at Scala. Scala is a combination of object-oriented and functional language. Its collection hierarchy in version 2.8, which is currently a release candidate. It's not production ready. It's not actually released. It's a release candidate. But he's actually published what the collection hierarchy looks like. And at its root, there's a class called, or an interface called traversable. There's an interface below that called iterable. And then you've got the various things hanging off the hierarchy, map, set, and sequence. And you can see it is a hierarchy, right? Getting back to that age-old idea that, hey, we can actually have things with commonality all the way down. And at the iterable level, you have, once again, a very rich and humane API with things like, in the Scala terms, you'd have filter and filter not and reduce left and group by and min and max. And I'm going to stop ranting them off and just move on. But the point is, it's got a very rich API available in it. Getting back to the, some of those things I think he believed, he learned from history, things that came before him. So back to Vlad.
Thank you. Right. So, as we mentioned before, it's not about types, or it's not all just about types. Yes, it helps to have a consistent type hierarchy that's actually hierarchy, but ultimately it's about what is it that you can do with the collections in your hierarchy. And so what we want to do here is highlight the difference between minimal API, which is the philosophy that Java Collection Framework subscribes to, and humane API. And the idea behind minimal interface is to boil down API to the smallest possible number of methods that will still allow you to accomplish anything you want to accomplish, but really no more method than that. Whereas humane API, the developers of humane API try to figure out what is it that you're trying to do, and then provide as many methods as it makes sense to help you achieve what you're trying to achieve. Now, the differences go deeper below interface, and they touch on other things like efficiency and performance and so on, but for now we'll stick with the interfaces. And also from an implementation perspective, obviously, humane API will have much more methods defined in it, but the actual internals of the class will not be much more complicated because there is still, kind of by definition we just gave, support the same basic functionality. And one good way to look at the difference between minimalistic API and humane API is to compare Java and Smalltalk. We limited comparison just to iteration-based methods, i.e. methods that run through elements of the collection to accomplish something, and don't really mutate the state of the collection. But that subset will give you a pretty good idea of what we're talking about. So Smalltalk defines all these methods. I mean, if you can't read them, don't worry. If you can, you could probably figure out what these methods do for most of them just by looking at their name. But what you could see is when it comes to iteration methods, there is a fairly large set of methods that cover some common and maybe not so common behaviors. Now, if you compare it with Java, And so we put together methods that do the same thing, although they may have different names. So if you compare it to Java, Java defines one external iterator, a couple of utility methods, and the toArray method. And really, the toArray method is necessary because if you want to do anything interesting with the collection, you can't define your own behavior on it, and there isn't much behavior defined for you. You can't pass behavior inside through some sort of, for each method that accepts closure because Java doesn't have it. And the only way for you to do it is to break the collection open and pull the data out. And in fact, in the appendix to the slides, which will be available for you online, you will see examples of how to array is used, for example, in the implementation of the sort method in collections. Right? So both components, again, basically order the same services. You can do the same thing with either one of the collections. But Smalltalk includes all this additional functionality, and this functionality is all relatively small things that could be built on top of Java's minimal interface. And since we mentioned Scala, let's look at Scala for comparison. Scala also provides humane API, as you could see from the diagram, and largely matches the API of Smalltalk, and in fact adds a few methods of its own. So, okay, we already mentioned that functionally all these collections are identical. So what are the real consequences of Java choosing this weak API, or as we'd like to call it, anemic API? Well, the consequence of that collection anemia creates pain. And this pain is, as we mentioned before, very much by design. So here you see a quote from the Java Collections API Design FAQ. And the question they answer here is the question on why Java doesn't provide internal iterators. And the answer highlighted in red is that it seems somewhat redundant to support internal and external iterators. And they also express concern with the throw weight of this functionality because it requires public interface to describe, well, effectively predicates that you would pass into internal iterators. Well, we frankly don't think these are valid concerns. In fact, the opposite appears to be the case. It's the external iterators that introduce increased redundancy and force developers to violate practices of good object-oriented programming. And we have listed a number of anti-patterns here that are caused pretty much by external iterators. In the appendix to this presentation, again, you will find a number of examples of these anti-patterns which will demonstrate in practice what are this pain that we're talking about. I mean, we'll go through it at the high level here. And the interesting thing to note that all these examples are taken from the actual JDK code. Naturally, the JDK code is not immune to its own problems, and why should it be? So, lowest common denominator iteration is, I guess, could be explained by this example. You could use indexed access to iterate over a collection, and it works very well for some collection types. Or you could use an iterator, and it works well for other collection types, but there is not a single approach that works equally well for all types. So, for example, if you try to optimize for performance, you have to figure out which type you're dealing with and then pick the right approach, which leads us straight into the next pattern, leaky optimization. And the symptom of leaky optimization is getting see an instance of in your code and effectively switch statements based on the collection type or the type of the class you're dealing with that pick the most appropriate approach for each given type. Reiterate pattern. So we talk about iteration, but you usually never iterate for the sake of iteration, right? Because that's kind of pointless unless you want to check that all the collection elements are still there. Usually you iterate to accomplish something, either filter, extract elements from the collection, find elements in the collection, or transform elements in the collection. And with external iterators, you will see these basic iteration implementations with all the gory implementation details appearing in the code over and over and over and over again every time you need to perform this type of work. And another manifestation of the reiterate pattern is that every collection library, actually with I think maybe 2 exceptions that you saw on the brief history of time slide, implements a for each method. So you have dozens of implementations of for each method that all do exact same thing on exact same data structure, incompatible with each other, and obviously completely redundant. And conditional thread safety. So we mentioned that collections in Java support only the most atomic operations. And from that it follows that synchronized collections also only synchronize and protect your most atomic operations, which again are not usually the things that you want to do to a collection. You want to do higher level units of work which will not be protected by synchronized collections. So you, the developer, become responsible for ensuring that the work that you do on the collection is done in a thread-safe fashion. And so the synchronization kind of leaks out, and you have to do all the check, and you have to take all the precaution yourself. Done?
Thank you. Okay, so this is the second quote from the Java Collections API design FAQ. So really answering the question why they didn't provide a predicate interface for doing interesting things like finding the first element that satisfies the predicate in a collection. And I think the clear point to identify here is that they didn't believe it would pull its weight. The Java designers basically thought, hey, it would actually just be easier to inline the predicate in the Java code. So let's step into what that looks like. So if you look at the select pattern, also known as filter in Scala, what you do in the select pattern is you create a new list, you iterate over some existing collection or list, you check some condition, and that condition is the predicate inlined in your for loop. And then if that condition is true, you add the element of the collection into the collection that you created. So this is what it looks like inlined with the nice for each loop available in JDK 5. Now if you wanted to optimize this for random access lists, you'd actually write it like this in the JDK. So my for loop is going to change. I'm actually going to have an index int, and then I'm going to actually use getI to actually get the value out. And this will actually be faster. The JDK itself and the random access interface tells you if your collection implements random access, this is the best way to actually do it. Now, this is the weight of implementing predicates inline in Java. If we take a look at other languages like Smalltalk, this is the way Smalltalk would implement it. So you have a collection, you have a method called select on it, and that select method takes the predicate, where a predicate in this case is a code block. This code block has a condition that gets tested, and it has to return a Boolean value. If we then look at Scala, so Scala's method name is different. It's called filter, but it also takes a predicate. It's a code block. It has a condition that gets tested, returns a Boolean, and this is the code. So you can compare the weight of the JDK implemented inline versus the weight of Smalltalk and Scala, and I think this is an example of predicate actually pulling its weight.
Thank you. Right. So how would we fix these problems? How would we get rid of this pain? Well, the most natural reaction would probably be to address the issue at the source of the issue, which is, in this case, enhance the JDK. Provide better alternative collections or a new collection hierarchy parallel with the existing hierarchy so that people who want backwards compatibility could have it. Provide internal iterators on the new or existing collection classes. Make collection implementation extensible, and what we mean here is right now collection state is pretty much always defined as private. So if you want to extend collection class, there isn't much you can do with that extension because you can't get access to any internal state of the collection. Making collection state protected would allow you to extend collection behavior and enrich collection hierarchy with your methods. Providing proper block closures would also help a lot but of course by itself it's not going to help you with the anemic API. Now, another somewhat more radical approach would be to use a better, whatever better means in this context, language with a better collection library. Now, obviously, it's a big decision to make, and I don't know if anybody thinks that there are obvious candidate languages, but you could look at Scala, Groovy, Python, or maybe we should just all go back to Smalltalk, which would be nice, and these are very interesting ideal ways to get rid of the pain, but let's check the reality and see how the reality is doing. Well, the reality number one is that Java is lava, as in lava flow anti-pattern that Donald mentioned before. The backward compatibility philosophy leaves us with no JCF improvement. Well, I'm just, sorry. I was going to say Sun, but this week it's Oracle. They're taking a very conservative approach, and it doesn't look like it's going to be changed. And you know, the block closure situation, that seems like it's changed, and they will be introduced in the language. But as I mentioned before, even with the block closures added, we still have anemic collections. Now, one could say, why don't we build a set of utility classes, a parallel hierarchy, if you will, which will operate on the JDK hierarchy and provide all this rich behavior that, that we're looking for. Well, we can certainly do that, but it doesn't solve the problems. It's actually just going to shift the problems elsewhere, and in the later slides we'll show you why it's happening and how it's happening. Now, reality number two, we need Java. There are billions and billions of lines of Java code that have already been written. I wrote quite a few of them myself, and so did you.
I was only 1 billion.
Right. So more continue to be written, and we don't really think there are any obviously credible substitutes for Java in the enterprise space. Scala is certainly an interesting language and offers a glimmer of hope. Scala 2.8 is right now a release candidate. When we put this slide, as I said a couple of weeks ago, it was still in beta. But release candidate is not something that you go and to take and deploy enterprise-wide, and even if it were a well-established version with a new well-established collection hierarchy, there is still an issue with Scala governance model, which is frankly not enterprise-friendly. So the conclusion here is that Java is not going to be replaced by Scala or any other JVM-based language or otherwise in the enterprise space anytime soon. So reality number three, developers start taking matters in their own hands and start trying solving the problem themselves, which we call must collection patterns, where must is abbreviation for making up stuff themselves. And Cameron Purdy of formerly Tangosol and now Oracle, well, why is it everything Oracle? Odd. Made this very good comment when Google Collections were just released. I think it's great that they've done this and made it available. The only problem is that they're years too late to save many of us the work of writing this ourselves. And again, if you look back to the brief history of time slide, there is a tremendous amount of highly redundant work that went into solving the same problem over and over and over again. Right? So many companies, many developers just rolled up their sleeves and rolled out their collection frameworks. And of course, naturally, we've done the exact same thing. Donald?
Thank you. Okay, so our must answer. What we've actually done over the course of the last 5 years, we've actually developed our own collection framework called Caramel. It's an acronym. It stands for Collection, Array, Map, Extension, Library. So Caramel contains utility classes that provide consistent iteration over the Java collection types, which we included as map, collection, array, and string. It's also got replacements for the basic JDK types of list, set, and map, so array list hash set and hash map. We have replacements for those. We also have interfaces that extend the basic interfaces, add a rich API, and basically are completely compatible with the existing API. We've optimized the memory footprint of all of our collection types because the places we were actually developing the collection framework were extremely large JVM heaps. Now, when I say extremely large, I'm talking about between 10 to 100 gigs of RAM allocated to the heap. So along the way, we've also implemented a bunch of collection types not available in the JCF, so like intervals, bags, multi-maps, immutable collections, lazy iterables. We've also, because we're working very large JVM heaps and dealing with very large collections with millions of items, it made sense for us to actually leverage parallelism once the number of cores in our boxes started increasing. So we've actually implemented parallel iterators as well. So getting back to, I guess, Vlad's point about, why not just roll this up in a utility library? Well, that's exactly what we did at first. We built a utility library in Caramel because we did not want to own a collections framework. So we looked to basically provide, if you look at the top, there are these 4 classes: iterate, array iterate, map iterate, and string iterate, providing iteration over the various types. Now, as we implemented them, and we went with the LCD pattern to begin with, just used iterator to iterate over the collections and provide the behaviors like select and reject and collect. What we decided was well, we actually started leveraging a collection framework called Trove. I don't know if anybody's heard of Trove in the audience. It's a very good framework. I definitely recommend going to look at it. They use internal iterators. And because they use internal iterators, we wanted to optimize our iteration over Trove collections, so we use their internal iterators. So we wound up having to implement a Trove iterate, which you see right next to the yellow operate. And then we said, well, we really want to optimize for random access collections, so let's provide another optimization out there for random access. So we have this list iterate class. And at some level, we got to the point where, hey, for our very large collections, we'd like to reduce the cost of the iteration itself. So we kind of crossed what I call the Rubicon, and really where it set us off to start creating our own types. We used what's called the Commando Anti-Pattern. It was described in the Java Performance Tuning newsletter, and I'll use their quote because it's really good. So the Commando pattern is used to get in and out quick and get the job done. This pattern can break any encapsulation to accomplish its mission. It takes no prisoners. So in array list iterate, what we actually do is we reach into array list, and we rip out its array using reflection and iterate over it directly. It's the fastest way to iterate. It's the most heinous and horrible violation of encapsulation ever. I never want to see my code. The nice thing is we built it into our utility framework. But really, it kind of identifies that fundamental problem of, we can't do anything with the types that are there. The array list type made its data member private. It's not protected. We couldn't even extend it and get access to it. So reflection was our only option. Now, it winds up actually being effective. It gives us about 20% speed up on the iteration for array lists at a threshold of about 100 elements. But what actually happens is the iterate class now has dependencies on all these various other classes, right? It's about 2,500 lines of code of just huge if statements checking the types, and it's just it hurts my brain as an OO developer to think well, that optimization really belongs on the type because it's got the fundamental information. So some of the other futilities of implementing a collection utility is that when a Java developer is sitting down in their IDE, the first place they're going to go to look for information about a type in the IDE is with code assist, right? They're going to dot in control space or whatever and actually, hey, here's my list of things I can do. The IDE isn't going to tell them that there's some utility out there that's going to help them do something useful. So you actually have to know that that utility class exists. You have to learn it. You have to learn its API, what types it deals with, so on and so forth. In the case of our utility library, since there is no root of the Java collection hierarchy, you have to know that there's map iterate and array iterate and string iterate and iterate, and maybe list iterate too because you want the return types to be lists instead of collection. So there's a lot of information that you as a developer have to know about the framework. So it's very obscure. Implementing in a collection utility library is also not very object-oriented, especially when you start writing code where you're stacking function together. It's actually hard to reason about. If I was writing it in an object-oriented way, I could actually read left to right and see, hey, I'm doing a select, I'm doing a collect. If I do it in a functional approach with a utility library, what I actually do is I have to see the select inside of the collect. I actually have to then read right to left. So it's not as object-oriented, and it becomes a little bit harder to reason about sometimes. The other problem with the collection utility library is it's incomplete. If you have problems in your base types, which were actually in the appendix, there are some things we can show you about array list, for instance. An array list In the JDK, it's the best collection that they have. But there are some actual basic problems with it. And you can't fix those problems by putting it into a utility library. So there's problems like in its add-all method. There's a problem in its equals method and hash code method, and you can't fix it. There's also like remove all and retain all, which you can see in the appendix. So the last thing is basically with the collection utility library, it's much easier to actually optimize for iteration once you're on the type itself. You've just got intimate knowledge about your data structures, and you can actually take advantage of that. So what we wound up, after we went across the Rubicon and, we did ArrayList iterate and we wore our Commando hats and blew things up, we wound up actually starting to implement our own collection library. And we tried to address some of those things where we wanted to have a hierarchy, right? So we could actually reason about our types. So you can actually see we folded our map class into our hierarchy. So map and collection, all the other collections actually extend off the same root. We also introduced a very rich API in the form of rich iterable, where various collections, whether immutable or lazy, actually share this common set of those patterns that we've already started talking about. So I'll hand it over to Vlad.
Thank you. So let's look again very briefly at this comparison of two different API philosophies. And this time we're going to add Caramel to the mix. And let's see from this diagram what Caramel adds to the API. Well, it actually adds nothing. There are no new methods. It's thoroughly unoriginal in its API. The only thing it does really is it implements all these behavioral patterns in Java. And I guess the question to ask is, so why? What does it mean to have all this rich behavior explicitly available in Java? Well, the next few slides illustrate the advantages of this approach. So we'll go through a few behavioral patterns and see the difference between stock Java implementation and how we would implement it with Caramel. And as a reference point, we'll also show Smalltalk and Scala implementations. So the first one is the one you already saw, select. And select pattern is very simple. We want to pick out from a collection elements that satisfy a particular condition. So really, the two key things here are, what is it that you're trying to do with the collection, which is select something, and that's the operation you're performing, and what is the condition? And so in Java, both the operation and the condition are obscured by the implementation details. It's the same example we saw before, so you see your Leaky Optimization there as well. And you really have to scan code line by line by line to understand what's going on, provided you haven't made mistakes scanning code. If you look at Caramel implementation, list select, operate greater than 50, basically the two key points jump out at you. You're trying to select things that are greater than 50. There is no parsing and mental compilation required. Now, of course, operate greater than 50 is not a standard Java construct. It's part of our predicate factory, and we use it, unfortunately, as a substitute for Java not having block closures. If we don't use predicate factory, you would have to write an anonymous inner class, which is not the same as closure, but I guess close enough. And with anonymous inner class, you immediately introduce this forest of curly braces that you still have to hack through to understand what condition you pass into your operation, but you still don't have any trouble figuring out what operation you're trying to perform. You select. Okay. Pattern. The next pattern is detect. It's different pattern, but again, we arrive to very similar conclusions. The intent of detect pattern is to see if the collection you operate on contains an element that satisfies a certain condition. And just like with the select, the key elements here are the operation you're trying to perform, which is detect, and the condition. And again, It's very much obscured in the Java code, and it's really not just visible in the Smalltalk or Scala or Caramel implementations. These are really the only two things that you see. Everything else, which are implementation details, completely hidden from you, as they should be. Now, another thing to point out here is that on the left-hand side, sorry, on the right-hand side of the slide, the predicates that you see, they're the same predicates that you saw on the previous slide. And so you see an example of predicate encapsulating this reusable behavior. And again, that's another example of predicate very much pulling its weight. Next pattern we'll go through is collect. So collect is when you take a collection, you iterate through that collection, perform transformation on the collection elements, and build the resulting collection out of the outcome of the transformation. So it sounds complicated, but it's actually quite simple. So in this example, we have a collection of persons. We want to build a list of names, so we iterate through the collection and build a list of names. And again, the intent and the type of the transformation are the key elements here. They're obscured in Java, and they're visible in all other implementations. And here is another bit of Caramel magic. With Caramel implementation, you see the selector class, which is really a way to create an equivalent of a block closure that will extract a value of an attribute or a chain of attribute on an object. Obviously, it's a bit clumsy. It uses strings to identify attributes, although we have ways to distinguishing that. And if you don't use that, then you use anonymous inner class. And again, the fact that you have to go through the tricks proves to me that Java is in desperate need of block closures. And there are many more patterns like that. And in fact, you start seeing a pattern of these types of patterns. And so what we did, we listed a number of iteration patterns here. It's kind of difficult to read, but again, you could look at it later when you get the electronic copy. And for even more detailed list of patterns, we would like to refer you to Smalltalk Best Practice Patterns books by Kent Beck that we mentioned before. So in the first column, you see iteration patterns expressed as pseudocode. And they kind of look the same, and they're hard to read, but they depict what you're trying to do with each one of the patterns. Detect, select, reject, any satisfy, all satisfy, collect, and inject into. Now, this is what it looks like in Java. And again, it still kind of looks the same, and you still have to squint hard and try to read every one of them to figure out what is going on there. And the code here just doesn't communicate its intent well. In fact, it communicates its intent extremely poorly, just putting them all together and seeing how alike they look. Now, if you look at humane API implementation, where we refactor these iteration patterns, the implementation details disappear completely, and the things stand out are the only things that matter, is what is it that you're trying to do, and what conditions, what predicates, what transformations you're trying to apply to that operation. And this is how, ideally, you should see your code and think about your code in terms of implementation patterns, in terms of behavior patterns, and not in terms of low-level language constructs that used to implement these patterns. It definitely helps to have support for these patterns and for these predicates in the language natively, so that you could just start your IDE and start writing code like that without having to go through dozens of libraries available and find the best one that fits your needs. But even when it's not available in the language directly, it should be present in your thought process. It should be how your thought patterns are organized, rather than thinking in terms of loops and lists and whatever. And you really need to be conscious about these constructs.
Okay, Well, I'm going to go through the conclusions fairly quickly so I can actually take questions. But I think it's quite important to understand, I think, the importance of collection frameworks in our lives as developers. The collection framework that you use really, imprints a particular culture upon you. So there's this quote from Mr. Noodle, which I'm not going to read. But I think, one of the important lessons we'd like you to take away from today is, you should study history so you don't have to repeat the old mistakes or make new ones. There's also, there's plenty of old languages as well as new languages that actually, I think, do justice to what got lost in Java. And I would recommend, learning those things, whether the old or the new. There's a lot of things out there you can actually learn from. So I'm going to add here, it's like, we can't offer you Caramel today, but we can offer you, in the appendix, there's a set of criteria by which, we use to judge a framework. Now, I would say for yourselves, as Vlad showed on the, one of the first slides, with all those frameworks out there, there are a lot of frameworks to choose from today. You really just have to understand what you're looking for and what's important to you. So you can look at our criteria. I wouldn't say that's your criteria. I would say, understand what you're looking for. And the really important thing is to focus on those behavioral patterns in your code, right? Say what you want to do and not how you want to do it. And don't let yourself fall into the, trap of getting lost in the jungle of curly braces. So with that, we can take questions, or we can do appendix, or whatever you'd like.
So questions or some examples in the appendix?
Any questions?
Okay.
Well, anything we could cover in 3 minutes from the appendix?
Any particular reason why it's not made open source?
Well, I was hoping someone would ask that question. So we're discussing it. We haven't made a decision yet. We really have to, I guess, evaluate what the, benefits of doing that are, what the costs and benefits are. So, yes,
Yeah.
like I said.
I mean, there is, unfortunately, more to it than simply posting it on SourceForge if we want it to be a viable contender in that space. So.
If you make different people use it, then you cannot actually evaluate how it works in some functionality.
In fact, we wrap on top of it, right? So I would say like Trove's a great framework.
Also having something like primitive site support?
Nope, we don't have primitive support. We actually use Trove for that. So Trove's definitely a framework I'd recommend looking at. There are other ones out there, like one of the first frameworks I looked at was Apache Commons Collections. It hasn't been upgraded much in many years. This is why Google Collections, I think, came out to really introduce generics that weren't being introduced into Apache Commons. And that's actually kind of the point as well, right? Is like all of these things winding up at the same place, right? And it really should be baked into the language. So while I would say go look at the frameworks that are out there, and you could pick one. Don't invent it yourself unless you're feeling eager and want to see how to do it. It should actually, as Vlad talked about in terms of the ideal, it should be baked into the language itself, right? We shouldn't have to be solving these problems. And I think that's why Groovy and Scala and Ruby and all these newer languages actually have it built into the language because it's so important. So they're like, if you looked at Apache Commons, for instance, they had a predicate utils class, which actually did something similar, right? You could get like an equal predicate or, not equal or not. No, it's like, that's exactly another type of thing. That's actually, we didn't talk about closures too much in this presentation, but really that's trying to solve the problem of wanting closures, right? Predicates are actually very easy to come up with a stock set of things because you can do equals greater than equals to, not null, is null, in, not in. There's like a whole laundry list of ones that you can actually implement, and predicates very easy to do that. And once again, so many different frameworks are having to reiterate that problem of not having closures. The ideal would be we have closures, which is what we're hopefully going to get in JDK 7.